All right, guys, we are going to be doing the copper mining lab activity. Please note that the background information has a great deal of important vocabulary, reactions, diagrams, notes that you will need in preparation for your upcoming exam on our unit on mining, soil, and plate tectonics. So what we're going to first look at is a piece of azurite. Azurite is the ore that contains metallic copper. So one of the things you'll need to do is make some observations about this piece of azurite. Okay, notice the different colorations, notice the different textures. Okay, this shimmery blue is actually a little bit like sandpaper. Okay, whereas this more turquoise is more rock-like in its texture. Okay, notice that there's some gray sections and some almost rosy looking sections to this particular azurite rock. Okay, so what we do then is we mine and we collect these ores. Okay, now we have to extract the copper out of the rock. So one thing we have to do is we have to get it into smaller pieces. So we pulverize it. So I have gone ahead and pulverized a small sample. It's about 1 gram of pulverized azurite. I'm going to add that to a test tube. Now, to extract the copper from the rock, we actually have to use a series of chemical reactions. So the first one, we're actually going to react the copper in the ore with sulfuric acid. And this is where we get our acid mine drainage from, because we have to get this copper out of the rock. Okay, so we're going to add the sulfuric acid. Okay, and you can notice right away that there are bubbles. This is known as a single replacement reaction. What's going to happen is, or what is actually happening is, the copper is going to replace the hydrogen. So we're going to end up with a copper 2 sulfate solution, and then these bubbles are hydrogen gas being given off. And you can see that the color of the liquid went from clear, sulfuric acid is clear and colorless, and now it's got almost a greenish tint to it. We're going to allow this to react for at least 20 minutes before we do the second stage of the copper extraction. So we'll take a break and we'll come back after the copper azurite has fully reacted with the sulfuric acid. All right, so now that we have allowed the azurite copper ore to react with the sulfuric acid for at least 20 minutes, you can now see that the solution went from a clear and colorless sulfuric acid to this turquoisey color of copper 2 sulfate. You can also see some of the remaining rock down here at the bottom. So now we're going to go into part 2 of the extraction process, where we get the copper out of the copper 2 sulfate. So to do that, we're going to have to do another single replacement reaction. We're going to react the copper 2 sulfate, that turquoise solution, with iron. Here's an iron nail. So I'm going to carefully put this iron nail into my glass test tube very carefully so it doesn't crack the bottom. So you can see it here in the test tube. I don't want any of the rock debris to go into my new test tube, so I'm going to make sure and filter that out. To do that, I take a filter paper, fold it in half one way, fold it in half the other way to make kind of a pizza slice, and then you open one side and turn it into a snow cone. That fits in your funnel. And that's going to go in the top of our test tube. So what we're going to do then is pour our copper 2 sulfate solution and let it drip through the funnel. That way we catch all of the rock debris. All of this rock debris we don't want. This actually goes into the tailings. This is what causes the acid mine drainage. We don't want this stuff. So this gets put into a basically trash pile and left out, and rain ends up moving the acid through the soil, causing acid mine drainage. So this is filtering. We're going to let it filter, and then once it's done filtering, we'll take a look at the result of the reaction. Please note how nice and pretty blue. We have this down here because we don't have any of the leftover azurite ore. You might also be able to see that the head of the nail is starting to discolor. That's solid copper actually starting to form on the tip of the nail. So we're going to allow this to react for about 10 minutes or so, and we'll come back and take a look at that after the filtration is done and the reaction has taken place. All right, guys, so now that we have allowed the iron and the copper 2 sulfate to react, we can see our final results. Notice that in the filter paper, we have all of that rock debris that was caught. So you will lose a little bit of the copper 2 sulfate. Notice it's tinted blue. Again, that goes into the acid mine tailings, or trailings if you want to call them that, that end up polluting the environment from mining process. Now, ultimately what we want is this copper coating that has formed on the iron nail. You can see that it's turned that reddish brown color. And if I shake it just a little bit, that all comes off and is a solid down here at the bottom. Once I shake all that off, now that allows more iron to react with the copper 2 sulfate. And you can already see some more copper starting to form on the iron nail. Shake that off, and it will keep going until there is no more copper left in the solution. That's the liquid part. We know that there's no more copper left because the liquid part or solution, excuse me, will turn back to clear. We will lose that blue tint to the solution part. And so that's how we get our solid copper. Then this is refined and turned into our copper wires or our copper sheets or whatever we need, the copper pennies, whatever we need the copper for. So this is the process of getting actual elemental copper out of an ore that we mine for in you know, a mountainside or a subsurface mining operation. So that's how we get our elemental copper. It's also how we end up with our acid mine drainage, because in order to extract that copper, we have to treat it with acid and then treat it with iron. And of course, what we don't want, we dispose of. It's that disposal that creates the acid mine drainage from the mining operation. So not only do we disturb the environment by digging it up through the mining process, but we also pollute it from the extraction process as well.